So the title would be Reactive Synthesis with Angular 2. I've been spending a lot of time looking at Angular 2, mainly because as the person who uses Angular 1, and we're a consulting firm will ultimately have projects with Angular 1 and Scala and other things in the back end, I knew it was coming down the pike. It was coming down the pike a long time, so we had a lot of different samples and a lot of iterations of the training. So in the middle of all that stuff, we had a trip to South by Southwest where we set up a booth and we were showing different Internet of Things devices and having them interact with temperature sensors and humidity sensors and things like that, just to kind of, have something for people to come to the booth and look at. And I recommended, you know what, it's Alpha 8 of Angular 2. Why not really make myself insane? So I said, well, why don't we do all of our instrumentation and graphing using Angular and Angular 2, not Angular 1. And I ran into this nice little thing called Observables. Observables are the secret weapon of Angular 2. You might think, okay, well, I know how to use promises. Most things end up being promises, and that makes some sense. For things that have single answers, certainly a single answer is a good thing to use a promise for. It's a little odd, actually, that one of the things that Angular 2 uses, the HTTP service, still returns observables by default because they kind of are single answer things. But if you think of, the observer pattern and a reactive front end, you want to have components that generate information for you, like we'll call those a subject in that graphic. You want to have the ability for different things to observe that subject and be notified whenever the subject changes. When you do something like that, you can have the state in one place, and as the state changes, your whole application can react in various ways. So what we did at South by Southwest is we used a WebSocket from a server written in Scala, generating output from these sensors, and we grabbed that information, put it through the WebSocket, Angular 2 picked it up, and we had an observable basically send a stream of information to all the other components to graph them and show charts of information. And early on, it made sense. It worked. It was easy to work with. We could adapt any kind of input into these observables and kind of emit data to other parts of the application. So early on, I became really interested in reactive JavaScript, this RxJS Microsoft library that they're using in Angular 2. And so I figured, for just because I'm a music geek and drummer and I like playing all sorts of instruments barely, I figured I wanted to play around with some musical synthesis, and this would be a good excuse to see what these observable APIs could do for it. So that's my mad science project. But just to kind of center on their RxJS or the reactive JavaScript a little bit more, the documentation for kind of the intro for it says, think of it as LoDash for events. Now, LoDash is a functional API. You can map and filter and reduce and all those things. It has an underscore dot. And then you use your different functions and chain them together in a very functional programming way. You get your inputs, you return an output, and you can chain these functions together. So as data arrives in RxJS, we can do exactly the same thing. Things are coming in as a stream of data. As each piece of the stream arrives, we can transform it. We can filter it and say, I want this piece, but I don't want this other piece. We can mute it because we don't want that particular one for whatever reason. We can combine or split the data. All sorts of things like debouncing input. So for example, if you don't want a type ahead search to happen more than once every half second, you can actually watch a field and the field emits an observable. You can actually connect to the stream of value changes in Angular 2 for a text stream. And as you're typing, you can say, you know what, get me that text stream, but I only want to pay attention to it every half second. So I don't care what you've done up to that half second, but when that half second has occurred, if you've done some activity, pass it through. So it's a very powerful way of composing streams of data. So here's a real simple observable. I used the lowest phi version. Observable has a lot of static methods in it, and we're looking at TypeScript here. But basically, observable.of will take a collection, for example, and it will emit it as individual emitted values. So we have 1, 2, 3, 4, and 5 in that array. And numberseek.subscribe in the next chunk of code, the first method inside that subscribe method is what method is called when you get each individual piece of data from the stream. And so that'll run 5 times. And so think of it as like an iterator kind of, but it's an iterator that is pushed to you. You're not pulling it, right? In JavaScript ES6, you can have generators, and you can say, generate me some data, and I'm going to pull the next value. I'll pull the next value, right, by using a next function, I think it is. In observables, the observable tells the thing that's subscribed to it the value shows up. And of course, you can have more than one subscriber, and so that's how you can hook synthesizers together and do all sorts of things by sending a stream of notes through a bunch of different pieces. And that's what I'm hacking around with here. So in this example, we're just basically returning the square of each value. So on its surface, it just looks like, okay, great, you're walking through a collection of numbers. But basically, you can start by generating fake test data like that in your service, and then move on to using a WebSocket, or move on to using a timed event. Like you can have an interval observable that every minute does something, and it will emit another answer to your subscribers. So that's what's really powerful about this. And it's baked into Angular 2. It is a core dependency of Angular 2. So if you're learning Angular 2, make sure you kind of set aside time to really get observables. All right, so again, so it's a push-based process. And so in a way, you know, we talk about reactive programming a lot. This is reactive programming. Your objects respond to stimuli when they happen. They don't have to keep polling for it or, you know, fetching it manually. So for example, here are some of the other places you might see an observable. One way is the HTTP service. All right, just like Angular 1, there's an HTTP service. I say just like in the fact that it has one, not that the API is exactly the same. It's a fair amount different, actually. But what's different about it is it, by default, returns observables, even though the observable has a single answer that comes back, which is a little odd. So for example, the http.get is returning an observable of type response. And the response has a payload, which is your data. Now, observables will have a lifespan, right? The one thing about observables that you'll learn early on is observables are either going to spin up, give you the answer and quit, or they're going to give you a certain answer for a certain period of time till it exhausts something and quit, or they're going to stay open until you close them. The HTTP observable there quits right away after it gets the first answer. So it's almost like a promise. It'll come back with an answer, which is your payload, and then it shuts down. So that's one place where you'll run into it a fair amount. I just learned about the next one because, believe me, I did the WebSocket completely manually at South by Southwest because I tried using the observable from WebSocket and it didn't work at the time, but it worked great when I tried it for this thing, and then I put it aside. But you can take that observable.from WebSocket and open a WebSocket and make all of its answers parts of a stream, which is really nice. Basically takes a lot of the plumbing away and makes it so that you can kind of throw that WebSocket stream through your system and things can subscribe to and pay attention to pieces of the stream of data, which is interesting. In my example, I'm using another type of observable called a subject. And a subject is an observable that you can programmatically emit data from. So you get a next method. And the next method, when you call it, tells all the subscribers, hey, I got another payload value. So what I'll do in the Synth demo is I will generate notes through these subjects. And as I'm typing on the screen or tapping on the screen, I'm generating JavaScript events that ultimately call a next on an observable called a subject. So some of the terminology here, all right, I'm throwing terminology around, so let's step back a little bit. The first term is observable. It's the observable object has general utilities to generate observables from various sources, as we earlier saw. And again, a subject is a special observable that can generate values and provide subscriptions. So it's both sides of the coin. You have operators. This is kind of like what LoDash has. Okay, so LoDash has, you know, the any, the all, the map, the for each, all those kind of things. They're called operators. And if you went to reactivex.io, which is Microsoft's site for reactive JavaScript and all the other Reactive APIs, and you looked at it, there's like 90 or 100 different operators you can use. It's a very powerful API, all with nice diagrams on how they're used. And then there's a thing called a subscription. When you subscribe to an observable, you have a subscription that you can then call close on or disconnect, I forget what the method is actually, and you can close down your subscription to the observable and stop getting events. So that's primarily what a subscription is for. It's a handle that you can use to basically unsubscribe. And those are the basics. So we've got these things that are observables that generate streams of data to subscribers. And subscribers can choose to disconnect when they're ready, and they'll be notified when it shuts down. So then you might wonder, why do I use promises? Well, you can use promises in a fair number of places. If you only need a single result for something, and you're never going to do a stream of it, well, the promise is just fine. And in Angular 2, you have the promise API built in, the ES6 promise API built in. They've got a shim for that automatically included. So if your browser doesn't support it, you have the promise API. So I'm not saying don't use promises. I'm just saying for anything where you can have multiple answers, the old way in Angular 1 was there was the notify method in the promise, right? There were 3 methods, and the last method was updates. And no API used it unless you programmatically used it. The problem with that was you can't really cancel a promise. So you couldn't, do that, and there was no composing of data. So the reason reactive JavaScript is so appealing to the Angular team, I believe, is because you could do those things. You could take it and you could cancel an observable when you're ready to shut it down, right? You could turn it off, and you can compose data from it functionally. And so those are the big benefits for it. So if you have those needs for a stream of data, if you have the need to have many listeners, things to react to it, or at least more than one, for example, an audit stream of something that's happening where you're going to want to sip that or log it as it's going along, maybe an observable will make some sense there. And also you have the ability to convert a promise to an observable, but I would just kind of say 90% of the time, don't do it. In fact, you also have the ability to convert an observable to a promise. If it's a one-shot thing, it's really almost the same signature. The first 2 methods of observable are results come in, error. That sounds a lot like a promise. Really is. If there's only one result, well, why bother going to the promise API? Doesn't make any sense to me. So you could switch between them just for things that are one shot. It's almost exactly the same thing. It's not a big deal to deal with it. The third method on a promise, an observable, by the way, is a close method saying we've disconnected, or we've shut down the observable. So it's message received, error, and then disconnected. Those are the 3 events in a subscription. So again, the HTTP client, HTTP, there's 2 T's there, API is one of the cases, again, that has an observable for all its results. And it's an odd one because it's a one-shot thing. The router, okay, so if anyone's written the router API code, done some routes, the very interesting part of the router is the activated route service. If you inject a component with activated route, it has all the information about how it got there and what's happening to that route. So for example, you can find out what URLs are being switched to. So maybe this is a component that takes a particular key and then brings back data, right? It's not going to destroy and recreate it if you route to the same thing again, change the key. It's going to keep it open, and it's going to update the data. So you're going to get an observable that tells you, hey, that just changed. The URL changed, the query parameters changed, the path changed, and so on. So that's another place you'll see a lot of observables. I mentioned briefly earlier that text input fields and things like that, drop downs, all the form fields have a value changes property. And that's something called an event emitter. And by the way, event emitters are observables in Angular 2. They're not the node event emitter. They're actually the RxJS observables and a subclass that they created called event emitter. So they're really doing observables. So you will be notified every time you type into one of those fields, and then you could do things like, all right, as I'm typing into this, I'm going to subscribe to the changes and value changes. I'm going to debounce it, meaning ignore it every half second, or at least take the last value of every half second, and then do an AJAX call. And you can even cancel the in-flight AJAX call that was running beforehand and say, all right, we got a new value, stop that one. I'm not going to pay attention to it anymore. So there are really cool things you can do with this. Also in form development, There are two ways to do validators in a form that are asynchronous. One way is to use a promise, and another way is to use an observable. So kind of weird because it's another one-shot observable that when it's done, who cares? It's over. You get the answer and it's finished. It's a one-shot thing. So the promise is actually easier to work with there. But also observables can be done for async validators. So there's a bunch of places, and there's tons more that you will see observables hiding in the APIs. All right, so my example is a dinky little musical synthesizer with a little bit of hardware too, because I had to get out more, and then I said, nah, it's more fun to play with electronics. So I've been coaching my daughter in soccer. I needed something geeky to do so I wouldn't go insane too, because, yeah. Anyway, so this little thing is going to be part of the demo. This is a Arduino type board called the Bare Conductive Touch Board. It looks like an Arduino Leonardo. It's a little kind of microprocessor, and it has a bunch of touch sensors here. Turns out this is a MIDI device. Turns out that the browser has a Web MIDI API, and thank you, Chrome. The Chrome browser has a Web MIDI API that you can ask for, and you can ask it to connect, and you can send note values through. So that's one demo. And another demo is an onboard keyboard, and another one is a drum machine. Very lo-fi, very cheesy, but it works. And it's interesting how little code we had to use to get it to work. So what I want to do is see if I could just get a nice non-latency, non-slow synthesizer working and use reactive JavaScript to do so. So that's what I want to show. And I also, at the same time, wanted to find ways to have an excuse to do different types of transformations on those things and have multiple subscribers for things like a volume dial and a waveform switcher dial. So as I'm turning those things, I've got different types of messages coming through this system that I can react to and work with. So I'm going to plug that in. And I'm also going to plug in the audio. It's alive. So in theory now we're all connected. So let's talk about what we're doing here. On the left, you see the inputs. We got these various types of inputs coming in. On the bottom, I have a service called the pipeline service. This is an Angular 2 service. It's a non-visual object. And that object holds on to a thing called synth stream, lowercase s. I typed it wrong. And by the way, you'll see a lot of developers use $sign at the end of these names. Not the Angular team, but kind of denoting that it's a stream. That's one naming convention that I've seen out there. So I use that in this example. So I've got this observable of a base class that has, note on subclasses, note off subclasses, volume change subclasses, and things like that, just to play around with some TypeScript and play around with this stuff. But the pipeline service holds on to the synth stream. There's a synthesizer service itself, which does the oscillators. So whenever you hit a note, the synth service's job is to subscribe to that note stream and say, oh, a note on was hit. Let me fire up a note object and play it. And that has an audio synthesizer oscillator in it, and it makes a sound. Then there's the destination service that it connects to, and I actually have 3 different pieces to this. Think of this almost like an audio mixer. We've got, first of all, there's a messed up thing about the WebAudio API, which is you can distort and overdrive it and make it sound horrific. If the volume of anything goes above the max volume, it gets horrible. So I finally have to pull my hair out, and believe me, it's mostly gone. After that, I found that if you use a compressor node in front of the audio going out to its output destination, you can keep it from clipping. So the idea is keep it from having the total gain or the total volume of all of your outputs being below 1.0. And that's what the compressor is doing. It's keeping it at a certain level and no higher. It's called cheating. I like that. So all of our notes are connected to the compressor as an we call it an output node. So all those are connected that way with WebAudio to this compressor. Then the compressor is connected to a master gain, which I've connected to a volume knob here. And that will be the total loudness of the whole system. And that is connected to the WebAudio destination, which will be your speakers. So, it's all doing it through observables, basically. And almost everything I do is either sending things into or pulling things out of a stream. So again, the main thing is the pipeline service. That's the thing that coordinates a lot of what we do. And I already kind of mentioned these things, but what I wanted to point out is basically there's a begin method in here that basically sets up all these pieces. So we're passing it, and this object's job is to get the web audio context, and it passes it to all the different systems, and it also feeds it the stream of notes, for example. And just today, I had a drum machine that was a separate chain of objects, and I said, why am I doing that? And I folded that into the same stream and created a drum machine trigger message, and now every single thing in this is fed through one observable. And you'll see that it's got complete responsiveness as we play it. All right. So what are we doing when we sip from these services? Well, first of all, so realize as I'm typing, I'm generating messages. They go into the observable. And again, it's called a subject. It's feeding things in. Then everything that's connected does things like the synth service fires off the oscillators. The drum machine service plays audio clips whenever I touch a cymbal or a bass drum sound. The synth service also will flip the next waveform if I change it from sawtooth to square wave or sine wave and give it a different timbre. And then the audio volume is part of the audio output service. So the thing that has the compressor and the gain node and everything, that watches to see if the volume knob changes so it can adjust the volume level of the gain of the entire system. And also the coup de grace on this whole thing is that I've got a sequencer service too that I threw in. And now I hooked it into the stream and said, well, click record. And then whatever you do, hit stop, hit play, just feeds them all back as events to the audio engine and plays them again. It's kind of cool that way. It's definitely cheesy. It's not like it's a repeated looping thing, but it was really easy to do that. And so it's kind of a neat way of looking at moving of data through a system. I wouldn't say this is your hammer for every nail, but at least for things that have a lot of moving data, it's an interesting way to do it. All right, let's play. First of all, let's make sure I've started it up. That's always good. I have. So this is just Angular CLI. Oh, you mock me. It's because I'm on the wrong port, 4200. There we go. So we'll do the keyboards first. Now, one thing is I use touch events. So you can't just click the mouse on this thing. You've got to open it up in a browser that will, thank you, Chrome, in a browser that will let you emulate a mobile device to do the touch events. Or if you are a fool like me and you decide to use newer technology that sometimes crashes, you can have a touch screen. Okay, so I didn't say I could play piano. I don't know if I told you that. I'm terrible at it. Guitar, I can do a decent even flow. So first of all, let's take a quick look at the input service here and see how I'm putting this together. All right, let's see here. I should say the input component. All right, so here's the actual piano component itself. Let's see if I do this right. There we go. So it's just a plain old Angular 2 component. I'll zoom that out. It's getting a pipeline service that we built. That's the service that builds the audio input and sets up all the channels and everything. So it's getting injected with that, so we can then use the synth stream to play a note or stop the playing of a note. Now, earlier, I had this so that whenever I let go of a note, it would stop the synthesis engine. When I pressed down, it would start. When I let go, it would stop. And there's a little bit of a bug in my code where if I slide off of it the wrong way, it will never stop playing a note. So I stopped that. And for now, I'm just playing the note for half a second. But there's certainly the engine is built to do on and off note values. So that is literally just JavaScript. But what I did was I tried to abstract it even further and say, when I send a note in, it should be the note by its note name and its register number, 0, 1, 2, 3, 4, 5, 6, 7, 8. So in the HTML, come on, HTML. I'm using an SVG. And the SVG is what paints that keyboard. And you'll see the rectangles have the touch enter, touch end, touch leave is doing nothing for me. But you'll notice the method I have is play note, and it has like D3, E3, F3, etc. And then like the sharps, right? So what I'm doing is I'm sending those values in, and I'm translating those in the model of the synth note. So I have note mappings, and each note has a particular frequency value that it maps to. So send it a simple note, it translates it on the fly, and then it will play it as the right frequency. So when I do, it works. It also lets me build different types of keyboards. Has anyone here ever played on an iPad and played with ng2? Anybody? If you're a synthesizer person, or if you like synthesizers, this is like the best $9 you can buy. It's the coolest thing. But it's from the Moog Corporation. It is a synthesizer completely modeled after an analog synth. And they did things like this, where they put together a little palette with a key in it or a mode, so you can't goof it up. I'm always in tune. I'm not going to goof up and do something that's not right. Well, I can't play, so that would explain it. But minor blues, we're getting a little sadder now. And we can do modes. So easy to do different keyboards. All I'm doing there is just showing different SVG images in each of the components and sending it different note values in play note. That's it. Okay. Yeah, whatever. I don't know. That's developer tools yelling at me. All right. So next on the docket would be drums. Turn this up a little bit. Let me maybe not turn it up a little bit. Pretty easy to do. All I'm doing is loading web audio clips, and as I'm tapping on these different notes, I'm sending a message to play a trigger, and the trigger of the name of the instrument to play. So let's see how we take these inputs and we figure them out and parse them and do the right things with them. Let's look at the subscription side of this. So from the synth perspective, the synthesizer's job is to play notes from the keyboards. So one thing it does is it subscribes to the note service. Or to the note stream, I should say. So right there we say subscribe to the note stream, and if the message is one of these synth note on messages, go and create a synth note and play it. You don't have to worry about too much about the particulars. I'll show you the code repository at the end. You feel free to download it and play with it. But the point being that you can easily kick off that note, and that synth note is what takes the frequency, maps it, and uses an oscillator to play it for half a second. I had lots of other great goals for this. I didn't get to them, like having a clock. All right. Some other things are, if I'm deciding that I want to switch the volume or the waveform, I also want to be able to provide messages for that. And I'm sending them through the same observable. Now, this Arduino is doing this, I think, every 50 milliseconds or so, or probably even less than that. But as I'm turning the dial around, it's actually sending all these events through MIDI as MIDI notes of a special number that I'm picking up. And then I'm sending them through as these messages like waveform change. So I've got a dial that will change the waveform as I go through to 3 or 4 different waveforms. I forget, I think it's 4. And so as I'm playing here, see if this works for me. So there's a square wave, I believe. Pretty straightforward, and it's doing it in real time. No problem. Now, the thing is, the volume can't be done in that component. The volume of the entire system is done in that final audio output service, right? Because I've got the compressor. A gain node is like a volume control I can turn down and up, and then it goes to the speaker through the destination in web audio. So to do that, we subscribe to it in there. So that looks like this. Where's the destination service? We call this the audio output service. So this one is only interested in a message's instance of volume change. All right. So the idea is all these things are coming through the system, and you'll subscribe to the ones that you want and act accordingly. Now, there are some things we could do to make that better. One of the things we could do to make that better is we could filter out all the messages we don't care about so that we don't even look at them for the if statement. We could just say, let's filter them all and assume they're only going to be a volume change. And I did that in another place in the code for another effect. But now, if I want to turn the volume up and down, pretty, I'm terrible piano playing, but that works too. Now here's yet another thing that I've done is we have an input service. In addition to these services that are the touch keyboards, I have a MIDI input service. Again, I mentioned the MIDI keyboard controller is part of this thing here. And as I move my finger across, turns out that that is done through something called the MIDI input service. And that one adapts a MIDI message and sends it as a specific note on value. So it sends the same message through the observable, and it's just grabbing it from the MIDI API instead of grabbing it from a touch event. And it all works. So, and by the way, that's where we're getting the dials from too, because there are MIDI on and MIDI off notes that are part of the standard of MIDI, 80 and 90 hex, and then 144, 128 for those who care. And then the other ones I found a particular MIDI note area like 145. That was supposed to be a controller message, and I used that and had basically 3 different settings, which 2 of which I've wired. One for the synth sine wave, whatever. One for the volume, and then one was going to be like a modulus or a warble kind of sound effect. But you can do that very easily. So that's pretty much it. So the bottom line is, observables themselves are pretty easy to work with once you get into it. You are able to tap things and pay attention to what they're doing, subscribe to things and filter out things you don't want. Send different types of messages of a certain class through if you want to. If you look, this is probably not the best design, but it worked for me. The synth note message file has all the various types of files or messages that go through. And I think I could refactor it so I don't even need that little message on the inside, but it was just to help me debug it.